But that's not it.
What if you,
No, we have to integrate this, yeah.
you subtract one of the tangents and make it a tangent squared theta, secant theta, tangent theta, d theta, and then do substitution?
Close. You're on the right track, but what you're going to do is take that tangent and attach it to that secant, and your whole du is going to be tangent theta, secant theta, d theta.
Yeah.
Yeah, I'm going to go to another page because it's too big.
I think I'll make this except for. Which is a C. That's a tangent, yeah.
I like to put all of mine in one thing together to remind me that that whole thing is going to end up being my d whatever.
So we made a secant theta minus 1.
Yes, secant square. Since this is an aside, 1 plus the tangent squared equals the secant squared, then tangent squared is secant squared minus 1. So I'm going to replace that. And the reason we did it is because now I can make u secant theta, and what's the derivative of a secant?
Secant tangent.
Secant tangent. So I'm going to now split this into 2 separate integrals, one that looks like secant squared theta times tangent theta, secant theta, d theta, minus 9 times tangent theta, secant theta, d theta. And that's old distributive property. This is going through, and then this is going through. And the integral of a sum or difference is the sum or difference of the integrals. So what the author says in section 8.3 is we're going to let this u now be secant theta, then this becomes du, and so this is really a u to the n du problem. So that's going to integrate to a secant cubed theta over 3. And that piece, what's the integral of a tangent secant? Yeah, just a secant theta. Right? If you go look it up in the front cover of your book. So yeah, this one just integrated right away. So this is a secant theta. And this we can do a little cleaning here. I know you're not done yet. We got to find that little right triangle. Yeah. So if somebody could remind us, oh, maybe I'll go to another page. What was our little let statement?
X equals.
But tangent equals opposite over adjacent, opposite over adjacent. Yep.
1.
can't do secants, I have to turn them into cosines in my head, so let me see. Cosine is adjacent over hypotenuse, so I need hypotenuse over adjacent. So I've got 3 hypotenuse over, oh, thank goodness, it's over 1 cubed minus 9 times square root of 1 plus x squared. Can't do anything too cute here. We could rewrite this as 1 plus x squared to the 1/2 and then times the 3. So really to the 3/2. Oh, let's do this. Let's factor that. I just taught this factoring in 1105. What comes out of each one of them? A 3 comes out. A 1 plus x squared to the, yes, to the lowest exponent you see. And that's going to leave 1 plus x squared, so 3/2 minus 1/2 is 2, oh, to the first, and then minus 3.
If we didn't simplify, would that be wrong in the test?
Well, this one's not multiple choice, so you shouldn't have to worry about it. But when we get around to some multiple choice questions, he does like to factor. The same person who did a lot of answers in the back, I think, wrote the test questions, and they love to factor. Now, there's a Calc 2 problem. See how big that thing was? You have to know an awful lot of trig.
That's a freaking page.
More than one.
Well, no, I mean, I'm talking about like that's one of my pages.
3. Oh, it's only 3 pages.